So this is the Unit 4 test review. So using ordered pairs shown, create a relation containing 3 ordered pairs. So these are your coordinates with a range. Range is your y values. So I'm going to label all the y values. Remember, the coordinates go x then y, just like the alphabet, x then y. So we have to do -1. So which y is -1? Here we go. -3, -1. We have a y value of 2. -2, 2, and a y value of 4, so 3, 4. So, all right, number 2, we have the domain, which the domain is your x values. So we need to think x-axis, how far left does the graph go, and how far right does the graph go? So looking at the actual graph itself, we have the left part is an arrow that goes left. How far left does it go? It goes left forever. Forever is not a math term, so left is negative numbers down here, and we're going left forever, left to negative infinity. How far right does the graph go? So it's going to go right, keep going right, keep going to the right, keep going to the right, keep going to the right, it keeps going to the right forever. So right forever, positive numbers, and right forever is going to positive infinity. You can write a plus if you like. So this would be negative infinity to positive infinity. That is not an answer choice, but what this really means is every number possible that you've ever heard of. So that is all real numbers. All right, number 3, which number is not an element in the domain of? Okay, so I take the word not out, and then every answer that is true for this will be not an answer. So which number is an element of the domain? So x values. So I'm going to go all my x's here. So -2, that is part of the domain, so no. 0 is part of the domain, so no. 1 is part of the domain, so no. 6 is part of the domain. That's not a choice. Only one left is A. All right, which of the following represents the domain, the x values? So the farthest most left point is right here. The domain, the x value is -3. Doesn't matter what the y value is, it's all about the x value. So it starts at -3. Think it right there, -3. And how far right does the graph go? Well, both the top part and the bottom part go right forever. So right forever, it's going to go to positive infinity. So -3 x value to positive infinity. It's equal to on -3 because there's an actual part of the graph is there. It's a closed point, part of the function. So -3, and it's x because it's the domain. All right, I know number 5, it said domain again. I wanted you to cross that out and put range. So it's the exact same graph, but range is the y values. So think about it. What's the lowest point in the graph? So the graph goes down, keeps going down forever. Down forever is awesome, but that's not a math term. Down forever is down to negative. And think about it, the y-axis is a number line going down to negative infinity. How high will the graph go? It'll keep going up forever, up forever. Up forever, it keeps going up to positive infinity. Which negative infinity, the y value, to positive infinity, never equal to negative infinity or infinity. Those are just thoughts. That's not an actual number, so it can't equal it. So no equals there. And that is all real numbers. All right, for B, what is the value of x minus 5 over x plus 2 when x equals 6? And we got to put the answer in simplest form of a fraction. So x is going to equal 6, so let's substitute 6 in for both of the x's. The numerator, simplifying that. 6 minus 5 is 1. Denominator, 6 plus 2 is 8. 1/8. That's already simplified. That's it. 1/8. Next one, x is going to equal -9. So we don't know what the y is. That's what we're actually solving for. -4/9 times x minus 5. Multiplying fractions, multiply the numerators. So -4 times -9 is 36. 9 times 1 in the denominator is 9. 36 divided by 9 is 4 minus 5. The y value is going to equal 1. Oh, -1. for number 8. So this is a different form. So what this is saying is the x value equals -7, because it's typically f of x. You'll see it over here as f of x. So it's saying x value is -7. What's the y value? That's what it's asking. In that little f of -7, that's what that means. So on the left side, this is notation. Nothing is really used in solving. And we have -7 minus 3 is -10. And -10 squared. Anything squared is positive. And 100 plus 1 is 101. So 101 is your answer. So when the x is -7, the y value is 101. So next one, we have g of -5. So this means x equals -5. So we're going to substitute -5 in. So when the x equals -5, the y value is going to equal, let's figure it out. So we have order of operations. We have -5 squared is 25, positive 25. -2 times -5 is a positive 10. 3 times 25 is 75. Let's carry this over. 75 plus 10 is 85, minus 5 is 80. So when the x value is -5, the y value, so g of -5, equals 80. F of 4. So that means when x equals 4, we got to substitute that in. So 4 minus 3 over 2. 4 minus 3 is 1 over 2. Opposite of 1, or you could think of this as like a -1 here, times 1. That's a -1 over 2. So when x equals 4, the y value equals -1/2. On the back, which of the following graphs appears to be a function? So function, so you can do the vertical line test. So I'm going to take, I don't even know if this actually works. So if you can draw a vertical line anywhere on the graph and you can hit more than one point, that is not a function. So not a function. You can draw a vertical line here. Excuse me. Not a function, hits many times, so not a function. This one, we're going to assume this graph goes in that direction forever. So you can draw a vertical line anywhere in there, different vertical lines. They always only hit once, one time. So that is a function. The next one, draw a vertical line, not a function. So B's got to be your answer. So which relation is not a function? So you could think a function, so you could cross out the not. Function is when the x's don't repeat. So 2, 3, 4, 5. 2, 3, 4, 5. That is a function. So that one cannot be the right answer. The next one, 6, -4, 6, 1. That is not a function. So that should be the answer. Next one we have -1, -2, -3, -4. That is a function, so that can't be the answer. 7, 1, -1, 0. That is a function, so it can't be the answer. So the only one that is not a function is B. Which graph appears to show a relation that is a function? So do a vertical line test. Draw a vertical line right here on that vertical line. It's hitting everywhere. That is hitting an infinite amount of times, not just once, but way more than once, so that's not a function. So nope. You can draw a vertical line anywhere on C, and that works. Anywhere on B, it hits once, hits one time, intersects one time, intersects one time, intersects one time. So that is a function. And C is the same deal. Anywhere along here, only hits once, so that is a function. So all three of those, C, B, C, D. On the back, which relation is a function? So the x's repeat, so nope. Vertical line test doesn't work, so nope. Domain, the x's repeat, so nope. Try a vertical line here, here, nope. D. And which statement is true? Talking about a function. So a function, this is a function, so that it can't be C or D. And it is a function because there exists one y coordinate for each x coordinate. The function because it exists one x coordinate for each y coordinate. I'm going to say B. So there's got to be one x coordinate for each y. And that is your answers. Come to class with any questions. Be prepared for the test. Thanks.